So does everybody have that equation in your calculator, x squared minus 10x plus 16? Let's set the window. I mean, we could set it at anything because you're going to get a parabola, but since it asks us on 27 to evaluate from 3 to 6, let's set the window maybe from 2 to 7 for our x's so that we see specifically that part of the graph. And it looks like it goes a little bit below the x-axis there, so we'll just leave the y min and y max the same and see what it looks like. Okay, so if I pull this off, and let's just take a look at the graph here. Whoops, I got a pin out here. Let's try this again. Okay, what did I went from 2 to 7, didn't I? So this mark right at the edge out here is 2. Here's 3, 4, 5, and here's 6. Okay? So if I'm trying to find this area, I'm going to get what kind of answer if I evaluate it? It's going to be negative, okay? And the question asks you, state whether or not the definite integral equals the area of the region bounded by the graph in the x-axis. A graph may help, okay? So we would say negative area. That's about as short as I could write it. And that's really all we're looking at this point. Yeah. Opposite of area would work great. That's perfect. And remember, test-wise, I told you what I might have you do because we talked about this one other day before Thanksgiving break. I may ask you to give me something that's equal to the opposite of the area or negative area. And you could just draw a graph and show this same picture would work for that. I might ask you to give me one that equals the area. And you could draw any graph you wanted as long as the part that you shaded in to show me an interval that was equal to the area, that whole part has to be above the x-axis. And let's look at number 29 to talk about the other possibility. And 29 is sine of pi over 6x. So let's go back in here and type that in. I'm going to put pi x divided by 6 to make sure I get that x multiplied there. Okay, and we're supposed to go from 0 to 7 on that. So I'll set my window to run, well, I'll just go 0 to 7. Then we'll just see exactly what we're supposed to. My sine graph shouldn't go above 1 or below -1, so let's go, say, -2 to 2 to see it a little bit better. And look at the graph of it. Okay, let me pull this off here. And this one was 0 to 7 sine of pi over 6x dx. Okay, so if I'm looking at that interval, I have all of this area right here, and then it cuts off right here. So I've got this little piece that's below the x-axis. So if we're choosing, we have a choice of the opposite of the area, equal to the area, and what would this choice represent? Not the area. So if I ask you on the test to give me a sketch of a definite integral where your answer would not be equal to the area, you need to show me a graph and pick intervals so that part of the piece you're finding is above the x-axis and part is below. Okay? Does it matter if they're equal? Like if you would get a 0 when you added them together, or what do you mean? A lot above and a little bit below. It would still not be the area as long as you have some of it above and some of it below. It doesn't, right, it does not matter if the two areas are equal. Yes, Felix, if they add up, like if the top part, the positive part, is exactly the same as the bottom part, which is like if we would have done this one, number 20. See how we got 0? That was some sort of graph there, and if we graphed it from -3 to 3, we would have an equal amount of area above and below, and we would say that that was not equal to the area. Okay? Any other questions on that part? All right. Okay. There's the information they give you above 30, that section of 31 to 36. Okay? So on 31, it actually asks you what the integral from b to a of f of x dx is. Now, we talked about this not too far back today even. Felix, remember you asked the question if it, where was the a and where was the b? What did I say happened if we switched? Because normally the a is down on the bottom and the b on top. So what happens to our answer if we switch the top and bottom number on our bounds? Yeah, it ends up being negative. So this is the same as the opposite is if I did it in this order from a to b of f of x dx. So if I look back up at the information they gave me, this bound right here is equal to 7. So the answer if I switch is -7. That's one of the properties that we had that last day before break. Okay, how about number 32, where we still go from a to b, but we stick a 4 out in front here. What can we do with a constant that's sitting next? You can just pull it out, can't you? So this is the same as 4 times this integral of a to b f of x dx. Because we can always pull those constants out if they're multiplied times the whole thing. So we would take 4 times what? 7, and our answer is 28. Okay, and I may make up a couple here, but let's look at, well, 33 has you go from a to c of g of x dx. This is one of the properties we also had. So if this is a to b up here, that's 12, and b to c is 13, do you remember what we could do if we had them separated? This is like on a number line. If I have a here and b here and c here, and from a to b it's 12 units. Is it what, Felix? And from b to c it's 13. We can add them together to get the whole thing. Okay? Now, if they ask me to find, like on 34, they ask me to go from a to c on f of x up here, and this is the only information we're given about f of x. So I wouldn't be able to find number 34. They don't give me enough information. So you could put just cannot find. And that's the case on 34 and 35, because both of them ask you to find from a to c of f of x dx. And we don't know enough about it. We only know from a to b on f of x. Now, let's see. Let me make up a couple here, just to go along with what we did. I don't want to number that 35. What we did on Tuesday. And I'm going to have to stop this.